Okay, we are starting chapter 4 today. So again, we're in the pink packet on the first page. Just a reminder, I know I already said this to you guys. For those of you that are absent, your quiz on word problems and consecutive integers will either be with your next quiz or you will not see it until the cumulative exam, which is after this chapter. Okay? Chapter 4, just a little summary, is all about graphing. We did a lot of this last year. However, the wording and the approach to this chapter is very different than what we did last year. Even though we're still graphing lines, which are linear functions, a little different. Before we start, can anyone remind us what is slope-intercept form from last year? What is slope-intercept form? Gigi. Good. Y equals mx plus b. Do you guys remember what does m stand for from last year? Anastasia. Good. M is slope. What is b from last year? Should have more than just two hands. What does b mean? Y equals mx plus b. Or explain, what do you do with b when you graph? Gigi, go ahead. Good. B is the y-intercept. That's your starting point. We're going to talk a lot more about that tomorrow. Okay? Today, in the first lesson, we are going to solve multivariable equations for the letter that is bolded. So please do not go ahead of me here. Some of these are different than what we did last year. Okay? So we're now solving equations, not like solving for x and we get an integer or number answer. We're solving for a variable, but there are still going to be other variables on the other side. Okay? So let's look at number 1 together. I want everyone to circle the H. That is the one that is bolded or highlighted. So circle the H. Okay, and Luke B, just do what you can for now. Okay, first thing, if we're trying to get H by itself, what should we move first or what should we get rid of first? Will, what do you think? Good, how do we do that? By what? Good job. Let's get rid of the half first. So that means we need to multiply both sides by 2. Why are we doing that? You guys know that if you multiply by the bottom of a fraction, it'll cancel on this side. In other words, 2 times half is 1. These cancel. We're left with 2a equals bh. Okay, I'm having a problem writing today. Sorry, guys. And I want you to go back and make sure you keep the h circled. We still need to get h by itself. Nathan, how do we get rid of b? Good. Divide both sides by b. Okay, it's going to cancel here. We are left with h equals 2a over b. Now, what's wrong with the way this is written? Remember from our proofs, how should we write this? Brian C? Good. H equals 2a over b. Brian C, what property did you just use? When you flip it around, what's the property called? Hey, quit whispering him the answer. Good. Symmetric property. So when you're flipping something around so that what you're solving for is on the left-hand side, please don't ever forget that's called symmetric property. Okay. Any questions on that? Okay, why might you do something like this? Or why or when would you use something like this? Anyone have any idea? Gigi? Yeah. Area formula of what? Good. It's area formula of a triangle. So when may you use something like this? Anyone have any idea? Anastasia? Okay, if you're doing proportions. Okay, definitely. What about something more simple as to when you're given a triangle and maybe you're solving for h? Why would you rearrange it like this if you were solving for h? Yeah. Might be easier for yourself. If you have a triangle and they ask you, all right, find h. They give you the area, they give you the base, but you need to find the height. So that's one reason of why you might rearrange a formula. Now, do you really have to do this for solving for area or the height of something? No, but that's one method that you might do that for, or use that. Okay, number 2, the y is bolded. So I want you to circle the y. That's what we have to solve for. Now, before you start solving this, why would we do this? When would you get an equation into y equals form? This is a much easier thing to figure out. Let me say that one more time. When would you try to get an equation into y equals form? I should have at least half your hands up. Nathan, what do you think? Awesome. Why? Okay. Why would you have to do that when you're graphing? Well, good. That's the form that I think it was Gigi that told us y equals mx plus b, right? Yeah. So you need to have it in slope-intercept form. We did these last year. They just didn't get too difficult. So let's solve for y. First thing you need to do is subtract 2x on both sides. So minus 2x minus 2x. We are left with 4y equals. Now, do you guys remember from last year? What do we write first? The x term or the 8? Right? Good. Why? Okay. Luke B, why? You're thinking of standard form from chapter 9, which actually that could be part of the reason. But when we're graphing, think about the form. It would be. Anna, you want to add? Good. You want it in y equals mx plus b form, which, Luke, you're right. This is in standard form once we get the y by itself. But you want it to be in slope-intercept form all the time. Your book calls it function form sometimes. You'll hear me sometimes say y equals form. Okay? Okay, let's keep the y circled. Last thing here is get rid of the 4. Divide everything by 4. Now, last year, I'm pretty sure that I put your line under everything, and then we just divided by 4. Nathan, you want to try to thank you. You want to try to simplify for us? Or no, not sure. Okay. I want you guys to look at this for a second. How do we get from this step to the next step? In other words, how do we simplify? Maddie? Okay, so what would it become? You're right. Awesome. Good job. Here I am like saying, yeah, you're right. You're right. Plus 2 is your correction. So here's what Maddie just did. Negative 2 over 4 reduces to negative 1/2. The x will stay next to it, okay? And then 8 divided by 4 is 2. If this way confuses you, are you guys with me? Does anyone need me to show you a different way to do it? We're okay? Okay. In case you're not telling me the truth, you could have done it this way as well, where you just put one line under each of them divided by 4. Okay. You guys tired today? Yes. Okay. Just checking. Some of you guys are just staring at me like I'm crazy here. Okay, so anyway, either way, here's your answer. Please make sure it's simplified completely. Questions? Okay, let's go to number 4. Okay, number 4, I want you to circle the y. So same thing we've been doing. We need to get that y by itself. Alina, what's the first step? Good job. Step 1, subtract 6x on both sides. Let's rewrite what we have. Brian V, what are we writing first? The x term or the constant? Good job. Still getting y by itself. Marissa, how do we get rid of the negative 3? Good. Divide both sides by negative 3. Let's see here. Kevin, what does our answer become? Good job. Y equals 2x minus 5. Is everyone clear on how we got to that? Okay. I want you guys and girls to try numbers 5 and 7. Okay, try numbers 5 and 7. I'm going to skip around, so don't go any further than that. Just try 5 and 7. I'll give you 2 or 3 minutes here. So just 5 and 7. I'll be right there, Gigi. And make sure you simplify everything completely. You found it? Okay. Okay. You're good. I'll go change it. Did you do those problems? You worked on them? Keep this as an improper fraction, because remember when you're doing slope, like rise over run, it's easier if you keep it as an improper fraction, not a mixed number. Okay? Oh, geez, you're fast. All right, Alina, what did you get for number 5? Good job. Okay, let me ask you this, because I saw a couple people doing this. Why should we not change this to -1.5? Anna? Good. So this one that's negative, if it was a mixed number, it'd be really confusing when you're doing your rise over run. Keep this as a fraction all the time, improper or fraction. Okay, don't convert that. Also, I mean, you can put it as a decimal. I think you're going to confuse yourself, though, so leave it like that. Okay? All right, number 7. Brian C., what'd you get? Okay, you can keep it as, you can change it to a decimal, but it's easier if you keep it as a fraction. If not, when you're graphing, you have to go up 1.8 over 1. It's going to be really hard to get that exact. You know what I mean? Okay, so 9/5 x minus 5. Any questions on how to simplify 5 or 7? Okay, let's skip down. We're going to do this together. Let's go to number 10. Okay, number 10, I want you to circle the R. That's the one that's bolded. We need to get R by itself. This one's a little bit harder. First question is, what formula is that to? Or from, I should say, Brianna? Oh, you said circumference? Okay, it's area, but area of what? Good. Area of a circle. What does circumference mean? If it was circumference, what is the circumference? Luke B? Good. Distance around. So you're close there. Circle, area. You're finding the surface of the circle. What's the area? Okay, so the inside of that circle is your area. We need to get R by itself. First thing you want to do is divide both sides by pi. So divide both sides by pi. So we have A over pi equals R squared. We're still getting R by itself, so I'm going to circle it. Okay, now, how do you get rid of a square, or I should say an exponent of a 2? Anastasia? Good. Square root both sides. The square root of any variable squared is just that variable. So we are left with square root of A over pi equals R. Madison, what's the property called if we have to flip it around? Good, symmetric property. So if we flip it around, we end up with R equals the square root of A over pi. Bless you. Questions on that one? Okay, let's take a look at number 2. And we're going to do this one together. Yeah, let's do this one together. Or number 12, sorry. Number 12, and it's the last one we're going to do, but let's do this together as well. Okay, this one's not fun. Well, maybe it is fun, but this one's a little bit tricky compared to the other ones we've done. All right, first thing I want you to do, you guys tell me. What do you think, Brian? Good. Multiply each side by 3. So let's get rid of the fraction. Let's multiply both sides by 3. Okay, now technically you could multiply both sides by 3/4, but let's stick together here. Multiply both sides by 3. Goes away here. We're left with 3v equals 4 pi r cubed h. We are solving for r here, so make sure that you have the r circled. Okay, now what? Brianna? Okay, what else could we divide by? Save yourself some time here. Okay, and what else? Good. You can, if you want, divide all in one step by 4 pi h, right? We're trying to get rid of the 4, the pi, and the h. So divide each side by all of them. They're going to cancel on the right side. Gigi? Okay, hold on one second. So our next step is 3v over 4 pi h equals r cubed. Keep the r circled. Here's what we haven't talked about in a long time. I mentioned this last year, but not sure if you guys remember this. How do we get rid of something that's cubed? Gigi? So you're saying do square root? Is that what you're saying? Oh, you're trying to break down. No, if it was a radical, you would do that. Simplifying radicals is what you're thinking of. Good try. Anyone know how to get rid of a cube? Okay, I'm just going to tell you, and I'll briefly explain why. We are cube rooting each side. Here's why. When you're taking the square root of something, it's like putting something to the 1/2 power. When you are cube rooting something, it's like you are putting it to the 1/3 power. That's the easiest way I can explain this to you. So really, r to the third to the 1/3 power, which is the same thing as the cube root, 3 times 1/3 is 1. Did that make any sense? Okay, let me explain it one more time. The cube root is like putting something to the 1/3 power. Just like the square root of something is putting something to the 1/2 power. If you cube root something, you're really multiplying this exponent by 1/3. 3 times 1/3 is 1. That's why those cancel. Let me go back to this for a second. When we square rooted this, when you square root something, which is just your normal square root symbol, it's like you're putting something to the 1/2 power. These cancel because 2 times half is 1. Does that make a little more sense? You will not learn all that until Algebra 2. I just figured I would try to mention it. Luke B? You will not. It's just a challenge problem. I figured I'd try to make you guys think a little. Go ahead.
Would we be able to type in the decimal, like, so 4 to the coins or whatever power?
You can, but this one has variables in it, so you can't, your calculator's not smart enough to do that. Okay? At least as far as my knowledge, I don't think the calculator does that. Okay, don't worry about why the cube root works. Just something extra I figured I'd try to show you today. Again, that's not until Chapter 6 of Algebra 2. Okay? And no, they will not get that hard on a test in this chapter. Besides this one, all the other ones we did, you could see those. Okay, any other questions for me? Sure. Okay, open up your homework packet to, I don't know what page it is. I think it's the second to last page. Nope. Yep. Okay, turn to page 62. It looks like this. Page 62, it looks like when you're looking up here, the one to the right. 62. There's a guy sitting in a chair reading a book. Okay? All right, so listen, because the directions are a little bit different. So it's page 62 in the homework packet. It is a puzzle, but don't worry about the puzzle, okay? It says here, according to some students, what is the true purpose of homework? I will tell you the answer tomorrow. Just remind me so I don't forget. For each one of these problems, your job is to put them into slope-intercept form, which is y= form, okay? So these are much easier than the last two problems that we did together. So all you're doing is getting them into y= form, okay? Don't worry about the puzzle. Do not worry about listing the slope or y-intercept. All you're doing is putting them in y= form. You guys still have some time to get started. Brian C? No, just page 62. Just this one. There's only one page you have to do. I want you to do all the problems that are on here. You guys can decide whether you want to use loose leaf or not. That's your call, depending on how much work you need to show. There's loose leaf in the back if you need to. Make sure that your fractions are simplified completely, and make sure your slope is a fraction. Do not convert it to a mixed number. If your y-intercept value is a fraction, which this will happen, you may either leave it as a fraction or a decimal. Ms. Wingrove and I will go over this tomorrow with the answer both ways. So again, either a fraction or a decimal, that's your call. No mixed numbers. Is everyone okay? All right, good job today. Did everyone get a cookie if you wanted one? No, you can't get another one. Okay, have a good day, everyone.